Welcome. Derivative rules mastery is going to be the topic of this lesson. And yes, you already know what derivative is. And we also, in fact, introduced the derivative as a limit, right? But it's still kind of hard to find the derivative of a function because we need to evaluate the limit of difference quotient every time. And I can say that's cool. It takes time and takes a strength too. So we need to develop some new tool or maybe figure out some new rules. And that's what's going to happen today. We'll learn to find the derivatives in a much easier way, in a much faster way. So let's start. And actually, today we're going to work in this format. I'm going to write down the formulas, we'll discuss them a bit, and then we'll practice. We're not going to derive the formulas. However, I'm going to attach the derivations in the lesson notes if you want to check them out. But it's not really hard to derive the formulas. It's just basically using the limit notation, but we don't even have any other one. We define the derivative as the limit. Right? So you just use the definition and you work with the definition. Then you do some algebra, simplification, and then you try to recognize some formula. And that's it. That's just how we prove the rules I'm going to write down today. So let's start. Let me write down the first part of the rules and then we'll discuss them a bit. Great, so here we have four first formulas. Wonderful. First one says that the derivative of the constant equals 0. And that's really obvious because graphically, what's the constant? Constant, that's a horizontal line. What's the slope of a horizontal line? That's 0. Slope is 0. Yeah, sure, then the derivative is also 0 because derivative and the slope is the same thing. Slope of the tangent line is derivative. So yeah, 0, agree. Second, I even emphasize the second formula because that's arguably the most important formula here. The power rule. So if you take the derivative of x to the n, right, then you bring down the exponent here, and then you also have to subtract 1 from the exponent. And that's it. So this way, you can find the derivative of x to the n. And of course, we'll actually use it very often, very often. All right, the third and fourth formulas are very, very intuitive, clear, I think. Because look at them. So the third one says that if you take the derivative of the function f of x multiplied by c, you can pull the constant out to the front. And just look at that and remember the definition. Yeah, you can even do it in your head, in your mind. If you remember the definition, you will see that the limit of the difference quotient, right? And you will see that, yeah, the constant will be able to factor the constant, so it's not a problem. And we also know from the limit properties that, yeah, we can easily pull the constant out to the front, so it will work out 100%. So believe me, all the derivations are super easy. You'll look at the notes. I don't want to waste time for that here. So if you look at the notes, you will see the derivations. They're all clear. They're all easy. Great. And the fourth formula says that the derivative of the sum is the sum of derivatives. And the same thing with difference, right? The derivative of the difference is difference of derivatives. And that's also very clear, especially if you remember that the same thing works for the limits, right? Limits has the same properties. And what is definition of the derivative? That's again some limit. So when you will work with the limit there, believe me, you'll get to a point where again you will be able to use the limit properties, where we also said that the limit of the sum is the sum of the limits, and the same with difference. So yeah, you'll be able to prove these formulas, all the formulas. That's not hard. So let's just practice. I think let's practice. All right, so let's first find the derivative of, let's say I want to find the derivative of 5. What's that? 0. 7. 0. Thousands. 0. Okay, for any constant, 0. That was the first example. You've made it well. All right, second. Let's take the derivative of x cubed. So what do? We have to bring down the exponent, so 3x, and also subtract 1 from the exponent, right? So it will be 3 minus 1, 2. 3x squared. This is the derivative. And let's just try to evaluate the same limit, not limit, evaluate the same, find the same derivative using limit, using the definition. So we see that, yeah, the answers will match. Let's do that. Just one time. So you see, I'm not lying here. So what was the definition? F of x plus h minus f of x over h. So h approaches 0. This is our derivative. So it will be x cubed, x, so instead of x we put x plus h, so it will be x plus h cubed. Oh no. Right. Oh, actually, all right. So x plus h cubed minus x cubed over h. So if we expand that, we're going to get x cubed plus 3x squared h plus 3xh squared plus h cubed minus x cubed over h. So x cubed cancels out, and we'll be able to factor h and divide by h. So in the end, we'll get that it's going to be, of course, I forgot the limits. So finally, that will be 3x squared plus 3x h plus h squared. Yeah. And of course, if we substitute 0, we're going to get 3x squared. So as you see, it works well. The rules work well. Here, so 3x squared, 3x squared. And of course, this is much faster. All right, the first example. Let's find the derivative of 5 x to the 4th. It doesn't really matter. Why did I change it? I don't know. All right, so 5x to the 4th. And the constant just stays here. We don't care about the constant. We pull it out to the front. So constant's here. So what's the derivative of x to the 4th? We bring down the exponent. And then we also subtract 1. So it's 3. So the final answer is 20x cubed. Very easy. All right, let's clear the board. All right, next example. We want to find the derivative now of the polynomial sum. I know 3x cubed minus 2x squared plus 7x minus 1. So this is our polynomial. I want to find the derivative. Wonderful. So in fact, now remember the rules. We'll just have to find 4 separate derivatives. And of course, you can write it down this way, right? And so on. And so on, right? But I don't want to do that. Of course, let's just skip that part. And let's do it in your head. Yeah, of course, we do these, in fact. But it's like in limits. Yeah, of course, we have to write it down this way. But nobody will really punish you if you skip this part. So if you just write that, yeah, I pull the constant out to the front, so it will be 3. 3 stays here. Then I take the derivative of this function, so it will be, I bring down 3x, and subtract 1, 3x squared. Then I go to the next function, next part. Again, constant stays here. x squared. So it will be, I bring down the constant, 2, subtract 1 to x. And we move further. Now 7x. So constant stays here. The derivative of x, that's 1, right? So in fact, x is just x to 1. So 1 goes here. But if you subtract 1, you're going to get x to 0. So that's 1. So answer is 1. 1 minus, what's the constant? What's the derivative of 1? That's 0. So this is the final answer. Now that's 9x squared minus 4x plus 7. So this is the derivative of our function. So this is our f of x. Now of course this is prime. F of x is this. This is f prime of x. This is it. Alright, next example. Now we want to find the derivative of, let's also work with some fractions. I mean, as I told you, your exponent, you can even have some fractions in your exponents. Yeah, not a problem. Let's look at this. Let's say 3 square root of x plus x to the 1/3. Alright, like this. So let's find the derivative. It will be constant stays outside. Now we take the derivative of square root of x, but square root of x, that's just x to the 1/2, right? So it will be, so it's the same as, let's rewrite it as x to the 1/2. And it means that first you bring down the exponent, it will be 1/2, multiply, and you subtract 1. So it will be x to the negative 1/2. Okay. Then plus, now this guy, it will be 1/3, multiply by x to the 1/3 minus 1. So it's negative 2/3. So this is it. We can also write it down as, 3/2 multiplied by 1 over square root of x. And this will be 1/3 multiplied by let's just keep it this way, okay? 2/3. And that's it. So this is the derivative of this function. Again, just even if you have some fractions, anyway, that's what? That's an exponent in of itself. So again, the power rule works there. Wonderful. I guess that was enough for these rules. Let's move further and introduce more. Alright, so here we have the derivatives of all the other elementary functions. So the blue ones are trigonometric functions, green ones are exponential functions, and red ones are logarithmic functions. Wonderful. And in fact, there's no shortcut, okay? You will have to remember these formulas, sorry. But yeah, because even deriving these formulas every time, it takes time. Imagine you are sitting on the exam and you don't remember the formula and you have to sit and derive the formula. Right? That's not gonna work out. So yes, you'll have to remember the formulas. Okay, one thing to note, in fact, if you talk about trigonometric functions, you have to remember these two. Other four will be not so hard to derive using the chain rule. We'll learn the chain rule very soon. Next lesson, I think. Yeah, next lesson. Okay, but at least these 6 formulas are essential. They're super essential. Okay, but don't also forget about these ones. Derivation is good, but yeah, it's also nice to remember these formulas. So, I don't even know what to comment here. I mean, really specific, one is e to the x, right? And its derivative is the function, right? So the derivative of e to the x is e to the x. Nothing changes. So its derivative, it's just function. So that's the weirdest one. Basically, of course, here x is greater than 0. Yeah, it works for all the x's greater than 0 because our argument, the argument of the natural log, cannot be less than 0. So that's guaranteed, and cannot be equal to 0 too. So it should be greater than 0. And all the other things, basically, yeah, you just have to remember that's the base, right? Like the derivative of sine is cosine. The derivative of cosine is minus sine. Yeah, but I hope, I mean, now we'll practice and you will remember these formulas. Now, yeah, look at them, but of course, now we will practice, and for every problem, I will write down the formula we are going to apply. So, let's just start solving some problems. And yeah, then step by step, you will remember all of them. Alright, so first example, let's find the derivative of 4 multiplied by e to the x. So I want to find the derivative of this function. Then, very easy, we'll pull the constant out to the front. As usual, we don't really touch the constant. And then we'll work with e to the x. And what's that? And as we know, and I think that's not hard to remember, that's the only weird derivative. Because if you take the derivative of e to the x, you get e to the x. So nothing really changes. So therefore, I guarantee you, you will remember the derivative of e to the x is just e to the x. Nothing changes in this case. Wonderful, so nothing changed, right? Funny. Because constant stays the same, and then e to the x, and this derivative is e to the x. Alright, next example. So we want to find the derivative of 2 natural log of x minus 5. Yeah, sure. We have to remember the derivative of natural log. Let's also write it down this way. Is 1 over x. And x should be greater than 0. So we take the derivative and constant stays the same. Natural log of x. So that will be 1 over x. Yes. And then minus the derivative of a constant. That's 0. So the final answer is 2 over x. So this is the derivative of our function. And of course, we should guarantee that x is greater than 0. Next. Alright, one more. Now we want to find the derivative of e to the x plus ln x minus sine x. Yeah, I think that will be the last one because they're not super interesting. I mean, if you look at the table, and I have my table in my head, but then right now, for example, you watch the video, look at the table, and that's not hard. You just look at the table and you see, oh yeah, what's the derivative of e to the x? E to the x. What's the derivative of natural log of x? 1 over x. What's the derivative of sine x? Cosine x. And that's it. So it's not really interesting. But now, a few moments later, we will introduce quotient rule and product rule. And then, believe me, things will get much more interesting. So, okay, we take the derivative. First, we take the derivative of this function. That will be e to the x. Remember, the derivative of e to the x is just e to the x. Nothing changes. The derivative of natural log of x, that will be 1 over x. And minus derivative of sine x. And that, if you talk about sine and cosine, that's really easy. You just have to remember that, okay, the derivative of sine will be cosine. So you will have to change, right, from sine to cosine. And the same thing for cosine. But the only difference is that if you take the derivative of cosine x, then you'll have to also add the negative sign. So if you take the derivative of sine x, we will get cosine x. If we take the derivative of cosine x, we will get negative sine x. So we will have to add the minus there. And there are actually these formulas derived from these two limits. remember the limit sine x over x as x approaches 0. Yeah, so this limit and this also similar limit with cosine, yeah, they're derived from that formulas. But you'll see in the lesson notes. All right, I think that's all for now, because anyway, that's too boring. Now we need to learn the product rule and the quotient rule, and then the things will get much more interesting, right? All right, so next rule is the product rule. And guess what? If we have two functions, f of x and g of x, and now we try to obtain the derivative. And please do not do this mistake. It is not equal to f prime of x multiplied by f g prime of x. Okay? It doesn't work that way. So there is a rule, a product rule. Remember, there is a product rule which defines the products, yeah, the derivative of products. So, and rule says that derivative of the product is equal to f prime of x multiplied by g of x and plus f of x multiplied by g prime of x. So it's very easy to remember, as for me, right? So you just take, first of all, you write down f prime of x and g of x stays the same. Then you change the order, then yeah, f of x stays the same, g prime of x. So it's kind of, I can't say it's hard to remember. I think that's pretty easy. And again, that's not hard to derive the formula too. All right. And let's also write down the quotient rule. Yeah, so this is the rule for derivatives of quotients. So it will be, so if we want to find the derivative of f of x divided by g of x, then it's not equal to the f prime of x divided by g prime of x. Not even close to that. If this, even at least it's kind of close to the f prime of x multiplied by g prime of x, but this one will be super different. And here the formula is f prime of x multiplied by g of x minus f of x multiplied by g prime of x, and that's all divided by g squared of x. Yeah, it's not super easy. At first place you think, first of all you think like, yeah, I can say it's easy to remember, but believe me, somehow I remember that, you'll too. So you'll be able to remember these too, so don't worry. The product rule, the quotient rule. And actually they start very similarly, but the only difference is that here we have minus, right? And the order of the terms here is essential, because if you, for example, here in the product rule, if for example you first take the g prime of x and then multiply by f of x, and then you add f prime of x multiplied by g of x, you understand, if you change the order, that's not important. Nobody cares. Yeah, so it doesn't change a thing. You'll get the same answer because we have addition here. But this is here, that's super important, that first you take f prime of x multiplied by g of x, and then you subtract f of x multiplied by g prime of x. That's important. The order here is essential. So, and then of course you divide by g squared of x. All right, let's practice. And now the problems will be really interesting. All right, so first example. We want to find the derivative of x cubed multiplied by sine x. Wonderful. So we have to look at the formula, look at the function, and recognize the product. It means we have to apply the product rule. Logic, right? So let's do it step by step. Right, so f of x will be x cubed. So g of x is going to be sine x. Good. Remember the product rule. that will be f prime of x multiplied by g of x plus f of x multiplied by g prime of x. And yeah, sure, of course, you can also say that, okay, let me first take g prime of x multiplied by f of x, and then f of x, f prime of x multiplied by g of x. You understand? To change the order. So first do this and then do this. Yes, but I don't really suggest you to do so, because if you, I really insist on this order of things, let's say order of operations in the product rule, because then when it comes to the quotient rule, right, it will be very easy. You'll just have to change the sign and everything works well. Because here, yeah, order doesn't really matter in the product rule because we have plus. But in the quotient rule, the sign, so the order will be essential, right? If you change the order, you'll get the wrong answer. So therefore, please, it's better to do it in this order, right? So, and then you will just have to preserve the order and change the sign in the for the quotient rule, right? You'll have to change the sign and then divide by g squared, g of x squared, and you'll get the quotient rule. So I think, yeah, it's better to first f prime of x, then g of x, plus f of x, then g prime of x, okay? Wonderful, so let's do that. F of x, first f prime of x, right? So we take the derivative with respect to x of from x cubed. So that will be 3x squared, right? So we bring down the exponent and also subtract 1. Power rule. We apply power rule here. Then we multiply by g of x, sine x. Plus, now f of x stays the same, right? So f of x chills now. So it will be x cubed. And we have to multiply by g of x, g prime of x. We have to find the derivative now and multiply by g prime of x. What's the derivative of sine? Cosine. So that will be cosine x. So this is our answer. That's it. Good. Okay, next one. I think we have enough place. Let me change the color. Next one will be the quotient rule. X squared minus 1 over, let's say x plus 1, okay. I don't really care. So we want to find x minus 3. Let's better follow my notes, right? So I want to find the derivative of this function. Wonderful. So we need to apply the quotient rule. We recognize for 100% the quotient here. We recognize that. And we see that f of x, in this case, will be x squared minus 1. And g of x is going to be x minus 3. Good. So now we have to remind ourselves about the quotient rule. So that was f of x, f prime of x, right? G of x, change the sign, minus f of x, g prime of x, and we also have to divide by g of x squared. And that's it. Oh, I already wrote you the final formula, right? So this is already the derivative. So this is the derivative of the quotient. So it's f of x divided by g of x. Good. So we do the same thing here. F prime of x. Anyway, f prime. F goes first. F prime of x. So that will be 2x, right? Power rule. 2x. We bring down 2 and subtract 1. 2x and minus the derivative of 1. That's 0. So okay, that's only 2x. Then we multiply by g of x. X minus 3. Then we put minus and f of x chills. X squared minus 1. And we multiply by the derivative of g of x. So that will be g prime of x, that will be, so is the derivative of x, that's 1, minus the derivative of 3, that's 0, so that's just 1. And we have to divide by g of x squared, and that's just x minus 3 squared. And okay, let's simplify it a bit, but it's not super important here. That will be, what it will be, 2x, okay, let's 2x squared minus 6x minus x squared plus 1. So that will be x squared minus 6x plus 1 over x minus 3 squared. So this is the derivative of our function. Our function was x squared minus 1 over x minus 3. We found the derivative. Wonderful. So again, I can say that's hard, and I also can say that that's really hard to remember the formulas. It's fine. That's fine. That's fine. All right, let's solve a few more. All right, so more examples. Imagine we have a function. Let's actually denote it with y here. We'll say y equals 2x cosine x minus 2 sine x. So this is our function. And we want to find y prime, right? So we'll use different notation. Y prime. And y prime will be. All right, let's do it. So first, we have to take the derivative and find the derivative of this function. What's that? And we recognize the product, right? So we have to apply the product rule. Again, in fact, 2 stays here. We can always pull the constant out to the front. 2 stays here. Then we have to apply the product rule for x times cosine x. So that will be f of x prime, so x prime. Okay, let's write it down this way, right? X prime cosine x plus x cosine prime. Okay, this way. So n minus, right? Again, constant chills, and then we have to take the derivative of sine of x. Good. Now we just have to apply and recall all the table formulas, right? Derivative rules. So that will be, what's the derivative of x? That's 1. So here 1 multiplied by cosine x. F prime of x, that's just 1, right? Cosine x, g of x. Plus f of x stays here, multiplied by g prime of x. So what's the derivative of cosine x? That's minus sine x. That's negative sine of x. So when you take the derivative of sine, right, you get just cosine. If you take the derivative of cosine, you obtain sine. Of cosine, you obtain sine, but also with minus, right? Don't forget about minus. So this is it. And minus 2, and what's the derivative of sine? Cosine. We already discussed that. So this is it. And now, if we simplify the expression, we'll get that 2 cosine x minus 2x sine x minus 2 cosine x. That will be just negative 2x sine x. So this is the answer. This is the y prime. This is the derivative of our function. Good. Let's do one more. This one. 5x minus 2 over x squared plus 1. So this is, again, y. And we want to find y prime. Alright, y prime is going to be, of course, we recognize the quotient rule. So that will be, So this is f of x, this is g of x, right? F of x, f of x, f prime of x, right? So that will be 5x minus 2. We'll put prime here. Multiplied by g of x, x squared plus 1, minus f of x, 5x minus 2, multiplied by g prime of x. So that will be the derivative of x squared plus 1. And all over x squared plus 1 squared. Good. Now we just have to deal with this thing, with the denominator. And that will be, so what's the derivative of 5x minus 2? So we do it, in fact, again, we get, in our head, we take two separate derivatives, right? First derivative of 5x, so that we pull the constant out to the front, and we take derivative of x, that's 1. So 5 multiplied by 1, which is 5, right? 5 minus derivative of 2, that's 0. So that's just 5. That's everything that we're left with from this quantity. All right, then we'll multiply by x squared plus 1. So this is f prime of x. Yeah. And then we subtract, then minus. So we have 5x squared minus 2, of course, f of x. And we multiplied by the derivative of x squared plus 1. So we take, again, two separate derivatives. What's the derivative of x squared? That's the power rule. 2, we bring down 2, and we subtract 1. So it's 2x. And what's the derivative of 1? That's 0. So that's all here. Yes, and we don't forget to divide by x squared plus 1 squared. Now let's remove these from the board. So the final answer will be, I don't know, it's not even super important to simplify this. 5x squared plus 5 minus 10x squared plus 4x. And all over x squared plus 1 squared. So here we'll have minus, so negative 5x squared plus 4x plus 5 over x squared plus 1 squared. So this is it. This is y prime. Wonderful. I can't say something is hard today. I mean, everything is pretty simple. Actually, one more thing to note. Of course, sometimes that's also a kind of shortcut, right? Imagine you want to evaluate the limit. Yeah, you just have some limit, and you try to, I don't know, some strange limit, and in fact, so they want you to evaluate limit. It's just some limit problem, and then you recognize this form, right? And if you recognize difference quotient or any other definitions of derivative, then you can just, so in here, for example, we say we have a, right? So you want you to find some number. And if you recognize some of the forms of derivative, because we had multiple forms. So if you recognize some of the forms, then one of the forms, then you can just, then instead of taking the limit, evaluating the limit, you can just say that, yeah, that's f prime of a, and apply one of the rules and find the limit. That's just, let's say, a shortcut. If in some point in future, right, you will see it and solve some limit problem, and you'll say, oh, that's the derivative. That's the derivative definition. I can find the f prime of a here, and that's all. Now we can conclude. Practice. check the lessons notes. Yeah, where there you can find the derivations of most of the formulas. And yes, and for sure, just practice, and believe me, in time you'll remember all these formulas. And just do not avoid work, right? If you will work, everything will be fine. You will remember the formulas, and they will be in your head for the rest of your life. Believe me or not. All right, happy studying. See you in the next lesson.